Okay, so again, with the intersection and union of two sets, and there's some formulas to deal with that. That's what we're going to look at today. So just a reminder from yesterday. So inside the box is the universal set. So whatever it is we're talking about. Could be the set of all the students in the school. It could be the set of digits, all the digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Could be a set of playing cards, the standard deck of 52 cards. So the universal set. So every element of that set has to be accounted for here. Outside of the circles, these are the elements that are not part of set A or set B, so we call that neither A nor B. This area here is the elements that are only in A. These are the elements that are only B. These are the elements that are in both A and B. Okay, so this area of intersection. Right. So A and B is also known as A intersect B. Okay, and that's read as intersection. There are some formulas associated with this. So if we want the number in A union B, right, if we want the union is put them all together. So it's in A or B or both. Now, if all we have is numbers, there's a formula here, which says the number in A or B is the number in A, so you count everything in here, plus the number in B, you count all of these guys. But the problem is, you're going to have counted this twice, once as part of A and once as part of B. So the formula accounts for that and says we will subtract the number in A intersect B. We'll subtract the number in the intersection. And of course you could rearrange this formula. You could basically just kind of swap these two guys here and end up with the number in the intersection is the number in A plus the number in B minus the number in the union. Okay. Now, formulas, you're going to see formulas like this on your formula sheet. They're listed with a capital P, which stands for probability. So they're a probability formula. But anywhere you see a formula on your formula sheet with a capital P, you can replace it with a lowercase n and think of it as getting the number of. Okay, so the capital P is probability. That's a couple of units away. But you can replace that capital P with a lowercase n and do it for the number of. If the sets are disjoint, well, disjoint sets have no common elements, then the number in A union B is just the number in A plus the number in B. Okay, because there's no overlap. You're not double counting anything. The number in A subtract B. So this says get rid of B. So really what this translates to is A only, or only A. So A getting rid of the B. Now you're only going to see that in the textbook. Okay, in the on the diploma on that they'll say the number in A or only A. So it's the number in A minus the number. So number in A would be the total of those minus the number that are in the intersection because those things are in both A and B. So we just get rid of the ones that are in both. And if we go A union B prime, which is everything but what's in all of here, right? That's basically the universal set minus all the ones that are in here. Right, so it's basically what's outside. I tend to stay away from the formulas. Okay, I would rather think about the problem, label it in the diagram. So I always like to draw the diagram, put the numbers in the diagram, and then answer anything from there. It's a lot easier than sitting there working with formulas. So let's give that a shot. Ms. McKay asked 39 students if they like chocolate chip cookies or oatmeal cookies for favorites. 8 students like neither kind. So can we put the 8 anywhere? Where do they go? So they go outside the circle. Now we should label this. So there's chocolate chip, there's oatmeal. 15 students like both kinds. Can we put that in? No. Where does that go? Yeah, in the intersection, right? So 15 like both. 15. 6 liked only oatmeal. We put that in.
Yes.
Where?
The right circle.
Yeah. So where I wrote the 6, that's oatmeal only. Where we put the 15, that's both oatmeal and chocolate chip. The 8 was neither. We've got how many? So how many we accounted for? How many students do we have in the box so far? 29. But how many students do we have to account for? 39. So what's that mean? 10. So use the diagram, which we did. You know, how many students like chocolate chip only? Okay, C/O, so it's chocolate chip minus the oatmeal. So how many students, so I'm going to ask you some more questions. How many students like chocolate chip cookies? 25, right? The ones that like chocolate chip and oatmeal. How many like oatmeal cookies?
21.
21. Okay. So those are the types of questions we can answer. We just have to know the names of each of the regions. Neither chocolate chip nor oatmeal. Both chocolate chip and oatmeal. Only chocolate chip, only oatmeal. Ms. McKay asked 50 people whether they like tea or coffee. Determine the, we'll come back to that. We'll do it, but let's. Okay, 15 like neither tea, coffee, nor tea. Where do they go?
Outside.
Okay, so let's label this coffee, tea. Okay, we got 15 out there. 31 like coffee. How do we do that? 16 like tea. Can we put those numbers anywhere?
Yep.
Where?
You can put 31 in coffee, so they're 7.
But then that would say only liked coffee.
Right.
Okay, so here's what we do, right? We say there are 50 people. How many of them have we accounted for so far? 15. So how many people do we have left to account for? Okay, so we got 50 minus 15, so we've got 35 people left to account for. But how many people do we have to place? 47. So what does that mean? Some of them like both. How many? Okay, so we still have 47 people, right? But we only got 35 spots left. So 12 of those people like both. So now, how many only like coffee? So 31 minus 12, right? How many only like tea?
4.
Okay. How many people like both coffee and tea using the formula? It's 12. Or sorry, using the diagram is 12. Let's see what the formula gives us. So the number in the union, right? The union, that's everybody all together. Well, we know that 15 don't like any. So the number that are in the union is going to be those 35 people. Right? That's what we figured out here. The number that like coffee is 31. The number that like tea is 16. And this is the thing we're trying to find out. So that's what we don't know, right? But we can rearrange the equation. So let's kick this over to the left side and write the number in A intersect B is equal to, so right side stays 31 plus 16 minus the 35, which is 12. Right? Now that's what we did out here, sort of informally, right? We said, okay, like there's 4 regions. Any 2-circle Venn diagram has 4 regions. Outside, so neither A nor B. A only, A and B, B only. Right? And we just got to figure out, well, where do we put these? Which ones can we label, right? So up here, it's like, okay, we could put the 8 there, we could put the 15 there, we could put the 6 there. Only one number we didn't know. Easy. Here, a little bit tougher. Okay, we've got the 15 there, and then we say, but I got 47 people, and I don't know how to split them up here or here. Okay, but wait, I've only got 35 spots left, so I can't be putting 47 people in here. Okay, it's got to be 35 because I got 50 in here. These have to add to 35. Well, how do we do that? They're supposed to add to 47. Well, we say you subtract. So 12 people are doing both. Once you got the 12 there, this has to add to 31. So 31 minus 12, this has to add to 60. Ms. McKay asked 60 Starbucks customers what they ordered today. Okay, so we'll get there. All right, so let's go coffee, muffin. Okay, can I put the 40 down somewhere? Now, I know that inside the C circle there has to be a total of 40, right? But I don't know how to split it up. Can I put the 20 down? No. Can I put the 12? Okay. So outside, 12. So there's 60 total. We've dealt with 12 of them. Where does that leave? 48. But we've got how many here? Okay, so we have 60. From that, we subtract 48. Right? Because we only have 48 spots left, which means what? We have 12, and where do these 12 go? In the middle. So how many ordered coffee only? 28, right? Because inside the C circle, it's got to add up to 40. How many ordered muffin only? Okay, so inside the C circle, 28 plus 12, 40 ordered coffee. Inside the muffin circle, 12 plus 8, 20 ordered a muffin. 12 ordered something else. 12 plus 8 is 20. 22, 32, 40, 60. That adds up to the 60 that we have, right? So it checks itself in a sense, right? Inside this box has to be 60, right? And what we're writing down is the number of. Okay, so now we can go in here. So determine how many people ordered coffee and a muffin. So that was the 12 that we figured out. You can use the formula. Okay, so N, the number, in A intersect B. So the number in A, the number of coffee, plus the number of muffin, right? But now what we've done is we've counted the people that like both twice. So from them, we take away the intersection. We know this number, right? So 60, and we've dealt with 12. So 48 minus the union. So 48 is equal to 60 minus the union. So A union B is 60 minus 48, which is 12. So that's formal, right? That's like, let's use formulas. You'll never have to do that. Even if they ask you to determine, you can show the numbers just as we did over there in the Venn diagram. Okay. Actually, I think there was a question like that on the last exam. There was something with the Venn diagram where you had to basically take those numbers, work it out, and do this. But all they would care about then is you just have a labeled Venn diagram with the correct numbers. Okay, how you do it? So I stay away from the formulas, right? I would rather just think about it. All right, think about it. What do we got? Oh, we got the 12 people here. Okay, now what? Oh, I got 60 people. But wait, there's 12 here. There's 48 left. Right, but I got 60. Well, 60 minus 48 is 12. Those are the guys that did both. And then we fill in the rest. It's 35 students who like English or math or both. All right, give it a shot. See if you can fill this one in. Anybody agree? See some heads nodding. Falling asleep. Agree? What will take tomorrow? Get ready for the sinusoidal. Easy. Okay, so what do we know? So I started with the 4 said they liked neither. I didn't actually have to, right? 15 said they liked math but not English. So that's only math. 15 liked only math. 9 said they liked English but not math, right? So English only. And then the 4 here, so then we've got 24, 28. It's got to add up to 35. Now, so how many students like both English and math? So 7. Right? Determine and show your work. So as long as the diagram's there, you're good. Ms. Cheney surveyed 50 students that have fitness room membership to see if they do cardio 3 or more times a week or weight training. So we got cardio, weights. All right, fill it in. So a lot of this unit is analyzing situations, right? A lot of interpreting the language, right? What are they asking? What does that add up to? 36. So how many only weight training? Now, on the diploma, if they ask that, right, and you just do the diagram, but you don't put the 14 there, you're going to lose like a half mark, right? It's sort of like, you know, like you showed it on the diagram, but you never actually said what it was. Okay, so keep that in mind. If they're asking a question, they want an answer. Okay, this is showing your work. So, hey, here's my work, right? But you have to state the answer. Right? I did all the work, and it's 14. Okay, everybody agree? We see what we did. 100 students on PD day, or tomorrow, you could sleep in, or do homework, or both. So, how many are going to do both? Let's label. Generally on the test, I'll make sure that the circles are labeled, right? Because I don't want to have to, I want to look at one set of answers. So if I tell you this has to be sleep, this has to be homework, then the numbers have to be the same for everybody. Otherwise, people will be flipping it. I'll get confused. How's that look? So it doesn't say anything about the ones who don't sleep in or don't do homework. So we're going to make the assumption they're doing one or the other. So how many will sleep in and do homework? So 20. And answer that here. 20. All right, last one. 400 students were surveyed about grad. Okay, see if you can fill it in. What do you know? Ceremony, banquet. Ceremony, banquet.
50, 120, 200, 400.
So how many are attending both the ceremony and banquet? 280. Makes sense. So you see most of the ways that this thing can be filled in. What information are we given? What, we got to fill it in. Know the names of the 4 regions, okay, and be able to fill that in, and then understand how many have to be in the universal set. And I think it was like 5 minutes more than yesterday, but